Which is most true about internal validity? A, confounding variables limit internal validity. B, it requires successful replication within phases. C, it's a binary concept. Or D, internal validity is best shown in replication across studies. So A is the correct answer. Confounding variables limit internal validity. This is it's simple, yet it's really tough, I think, for a lot of times for both students and supervisees, which is when we talk about internal validity, a lot of times we pick words that are related to some type of validity, and then that's it. When reading this, it's saying what is most true. So we know we're looking for the most right answer. And then we have four options. We have confounding variables limit internal validity. That's the right answer. We have it requires successful replication within phases. So we're not ever going to have replication typically within a single phase. Because remember, the phase is us implementing the intervention or removing the intervention. So a baseline phase, maybe there's no intervention. Then our intervention phase, we are applying the intervention. Then a withdrawal phase, we are removing the intervention. And then the next phase, we are implementing the intervention. So this is tough because we see replication and replication within, which is a thing. It's just within studies, not within phases. But phases cancel this one out. So this one cannot be right. And then is a binary concept. Internal validity is not a binary concept. It is essentially the extent to which we can be convinced that it is our variable and not a confounding variable that is causing the change in behavior. So it's definitely not binary. It is not lights on, lights off. It is dimmer switch. It is how much can we prove? And the better, tighter our experimental design is, the less variable our data is, the more it changes both level and trend direction based on the phases that we implement. All of those can make us more convinced that our study does have internal validity, and the fact that confounding variables aren't the thing that's causing the change, that it's actually the independent variable that we're implementing. And then the last one is internal validity is best shown in replication across studies. So internal validity, it's like internal, it is within. So validity can be shown across studies, and there is potential where if you replicated a study 10 times and got the answers over and over again, there is an idea that if I replicated this and I got the answers each time, it potentially could strengthen internal validity. So this isn't untrue, but it's not the most true. A is the most right answer because confounding variables actually limit internal validity, because an extraneous variable is like a tornado watch. It's like it is possible that this variable might interfere and cause change that is not the independent variable that we're implementing. So maybe it causes change and not our independent variable. It's a maybe with extraneous variables. Tornado watch, right? It's possible that it could happen. Confounding variables means it happened, or there's a very strong likelihood that it happened. So it's like a tornado warning. It is like there is a cell that can make a tornado, or there's already a tornado on the ground. And in that way, confounding variables are like, it's very likely to have caused it, or we know for sure that it did. Confounding variables definitely limit internal validity because they make it way less likely. If it's confounding, it's already happened, or it's very likely to have happened, which means that whatever change is caused, we can't be sure that it's our independent variable. I separated this out just so you could have a visual of this. So experimental control, part of this is internal validity. And this is the extent to which an experiment shows convincingly that changes in behavior are the function of the independent variable and not the result of uncontrolled or unknown variables. So studies without a high degree of internal validity yield no meaningful statements about functional relations and really lack generality. This is me asking for reinforcement. Well, potential reinforcement.